Good morning, everyone, and welcome to the fourth installment of the Getting the Smarts webinar series. Today's presenter is Joseph Chi. Joseph is the Global Account Manager and Digital Transformation Lead at SMC Corporation, Australia and New Zealand. Over the next 15 minutes, he'll share how to create flexibility in your manufacturing environment and how to upscale or downscale your production during these uncertain times. During the presentation, please keep your microphones and cameras off, but feel free to write your questions in the chat area. At the end, we will answer your questions. So that's enough from me. I'll hand it over to Joe.
Thanks, Nick, and I hope you can hear me really well. Thank you for that very kind introduction as well. And first of all, good morning to everybody who's joining us this morning. Thank you for logging in as well. If you're joining us here, we appreciate your attendance as well. And also perhaps good afternoon to anyone joining us from across the Tasman in New Zealand as well. So we might as well kick off our presentation as well. So I believe, Nick, it's the fourth one now in a series of webinars. Yeah, so it's been a great lead up and certainly some great presentations from our members of Open IoT, and leading us to the point, I guess, considering smart flexibilities as a solution to upscaling or downscaling post COVID-19. So we've all been potentially impacted in various ways by COVID-19, and we may have found reasons that we previously didn't have to potentially overhaul our manufacturing and look into opportunities that we perhaps never considered before. So certainly we'll kick off the presentation now and head over to the next slide. So the purpose of this webinar as well is to explore a more simplified approach to digitalization through smart flexible solutions as well, which we have named smart flexibilities for the purposes we'll see and we'll uncover during the presentation and along the journey as well. So we'll be focusing on some of the key movers and motivators for doing anything around this incentive as well, and concept focus on starting the journey. One of the biggest most asked questions obviously is where to start. It is a vast concept as well, and we'll be exploring a few simple practical examples. Simplicity is the key focus here, is because the concept itself can be quite complex, and it can be quite intimidating as well at times as well, because it is quite a vast concept without actual structure built into it specifically or any guidance. So we'll be exploring some simple examples of where we can start the journey as well, and potentially we can have as many people relate to some of the applications. We're trying to scale these for as many budgets as possible as well. So for people with larger budgets or people on a more limited budget as well, but obviously need to make some improvements and add to their manufacturing process. So let's kick off onto the next slide then. And just in preparation of this presentation as well, I did come across a quote which was very appropriately in our energy saving journal or white paper that our colleagues in Germany have published as well. So I did quite like it, and I felt it was quite appropriate potentially even for the digitalization process. So it is about sustainability, and he was by a well-renowned architect and sustainability expert, William McDonough. The quote was actually, the Stone Age did not end because the humans ran out of stones. It ended because it was a time for rethink how we live. So we certainly have stones around today, and we certainly haven't stopped seeing stones around, but we have moved past that. And architecture, if anything, has turned many different corners over the period of time, and we've evolved. And perhaps not because we've ran out of stones, but perhaps we've found reasons to build in a different way or arrange the stones in a different way. So obviously, we're not here to reinvent the technologies or anything, but perhaps we can arrange the technologies in a much better way that would present us with a lot more value and have a lot more outcomes that are more positive in today's environment, or perhaps in a demanding environment that we live in at the moment. So, and manufacturing in. Interestingly enough, the whole concept of Industry 4 started in 2011 Hanover Fair, when 3 scientists delivered a press conference. And little did they know that the phrase that they've coined Industry 4 was going to be renowned around the world, and the impact that it was going to have even till today. So, but most importantly, the 3 scientists actually did have the message they were trying to share was that the future was here right now, and that was 10 years ago. And there was no doubt in their mind that the future was digital. So perhaps we don't all share the same opinion, but let's explore some of the options and perhaps some of the drivers that we need to consider in today's manufacturing process that may lead us down this path of having to leverage off digital technologies. So drivers for change, which we often refer to, and we're probably well commonly acquainted with a lot of these drivers, and a lot of the conversation has been around rapid machine adjustment as well. What does that mean in many ways? So, I mean, even since the start of COVID-19, we've seen bottling plants start manufacturing hand sanitizer. We have seen packaging machine builders start manufacturing mask machines. So we have very quickly retooled and repurposed our machinery. So rapid machine adjustments obviously can be applied to many smaller batch numbers or batches that we have to produce, mostly because now we're all familiar with the phrase from mass production to mass customization. Yes, it is familiar for many reasons. We have a lot more options in today's commercial markets as well, which resonate throughout the manufacturing process because we need to be able to keep up with that. So higher throughput, there's a lot more demand and a lot more expectations to be able to deliver a lot faster and the same quality of product, all at the same time at lowering our production costs. So we all need to find ways how to lower our production costs. Well, one of the ways could be through more sustainable resources as well, and potentially achieving the same results with a lot less. Could be another option. So higher functional demand. So what does that mean to our machinery? Well, perhaps our machines may need to do a little bit more. We need to expect a little bit more from our technologies. Perhaps it's no longer acceptable to design a whole line, a production line just for one product. We need to be more flexible with more functionality that we can incorporate multiple products in that same line. We need to be able to change the tool a lot faster. We can no longer have a machine sitting there for 12 hours or 6 hours at a time while we're changing tooling. So we're all familiar with these conversations and obviously drivers for change, but probably the biggest driver, COVID-19, may have presented us with a great opportunity to rethink how we are manufacturing today. And also, how can we continue to be competitive in our respective markets as well? So in having said that, what does Industry 4, what is smart flexibilities look like, and what is the ultimate promise? So moving across to that slide of the big picture, we all speak about the big picture, and we've all seen it everywhere, and probably the one we are most acquainted with in terms of Industry 4. So we see a gentleman holding an iPad in his hand. So possibilities of smart factories are almost endless. So and that can be a wonderful thing, but it can also be sometimes a cumbersome and almost a harrowing experience to a lot of people, not knowing where to start and what part of the process to consider. When we don't have boundaries around or a structure around a process like this, it's difficult to quantify, and it's difficult to quantify in many ways. Perhaps we can't quantify it from a technology perspective. We may not be able to quantify in a financial investment or resources or time invested. So, and we all know that nobody likes to write open checks, especially not these days. So, but yes, it is possible to hold a factory in the palm of your hand and be able to retool the machinery from a push of a button. But it's really important as well to understand that this is not the start of the process. This is the end result of the journey. And we need to keep that in mind. So there's many aspects along that journey and many stops along that journey that get us to that point. So moving across, in saying that, perhaps we've found enough reasons to start this journey. Perhaps we have already had enough reasons, or you may want to consider that now. But where do we start? So we might be in that situation. Do we look at installing more sensors? It's certainly been one of the easiest and most flexible ways to install a lot of sensors, and gathering data is very important as well. But sensors are not the only products that give you data or are able to give you feedback. There's many other products. There are actuators that can give you feedback. There are other PCs that we can add to the line that can give you feedback. There are more simpler devices out there that can also provide various forms of feedback that could have a large impact on the manufacturing process. So certainly that's one of the options, but where do we start? So let's jump onto the next slide and have a look what the journey looks like. So perhaps if we start with the roadmap, and that's a great way to start. And what that does is allows us to at least look at the 4-step plan. It's a quick 4-step plan that we've prepared as well, and we call the digital assessment. So starting with the first step, which is drivers for change. So the drivers for change, we've just spoke about them as well. So we all have them. We all know our processes really well. We know where we have shortfalls. We know what we need to improve. We know what our demands are. We know what we need to make up for. So we can start there. It's certainly advised from previous experience as well, personally going through the process as well with customers and reading up on what other customers have experienced when they've undertaken this process. It's certainly advisable to have one clear driver for change, or perhaps two at the most, because along the way we will discover more as well, and we'll potentially find things that we never thought of before previously as well that we may need to address. But it's important to have a starting point and a clear one at that as well. So perhaps it could be energy saving, perhaps it could be adding functional meaning to the machine that can repurpose the machine a lot quicker. Next step is our digital assessment. So it's almost a pin drop on a journey. So when we open Google Maps or we're heading off to a journey, we need to know where we're starting from to be able to map that route. So having a look, the digital assessment is almost a pin drop on a factory floor or on the machine. We choose the part of the process or a part of a machine or the whole machine perhaps, and we say, well perhaps we want to look at the energy efficiencies on the machine, or we want to upscale this machine and add more functionality to be able to process more product or different variations of the product. So we need to understand what that current machine has. We don't need to throw the machine out. We need to understand what the machine has. It's been estimated about 65% of equipment on the machines today has underutilized capacity, and we potentially only utilize maybe 20-30% of each component's capabilities. So there's probably a lot more scope in there to explore further, perhaps more memory in a PLC that we can utilize, perhaps diagnostics that we haven't considered. Perhaps we already have a network card that we're not using on that system as well. Once we've considered that, we need to know what we need to add to the machine. What is the machine missing that we need to add in terms of what we refer to as enablers? So what are these digital enablers that we need to add to our current system to create that ecosystem that's going to allow us to, to be able to achieve the outcomes that we set out to achieve? And finally, in the process, we need to be able to deploy that solution. So that it's very important that we create a project of a capacity or a size that we can deliver, and there's a start, a middle, and an end to it. And also that we are considerate of the time frame, the budget, of course. A lot of projects get to a certain point, they blow out in budget, and they never end up being finished. We also need to consider the expertise. Who do we surround ourselves with? Do we have expert suppliers who are experts in their equipment that can assist? Do we have hardware and software experts on hand? And do we need them? So it's just a little bit of planning that needs to be done around that to ensure that the project is completed. So in having said that, let's start exploring on our next step of the journey is we'll go through some of the drivers for change that we spoke about a couple of slides ago. And what can that look like? What are some of the simple drivers for change that we can address today? We can start today. We can have an almost immediate impact on our production process or a specific function on the machine or the machine itself, or even the outcomes in how the product is delivered. So let's consider energy saving, lowering the production costs. We all know that most of the machinery and most factories, or pretty much all factories, have a compressor on site and they use compressed air for automation. It's a well-proven method, very cost-effective, and can be extremely functional and accessible method of automation. So often machines, especially legacy machines that have been on site for quite a while, they develop leaks on those machines with artificial demand for compressed air. We often add to these machines without considering the demand of this energy. But what we need to do is we can simply, just by considering pressure and flow, we can control and understand quite a lot around what's happening on our factory floor. We can profile our entire factory by understanding what's happening, how much demand is on the machine, how much flow is being consumed by each line or each part of the process, and also what pressures are we using. One simple way is to reduce the air consumption is by lowering the pressure in the factories. That's something that we can explore. Using simple regulators. Often every machine comes with either a manual or a digital or electronic regulator of some sort. If we don't have a digital regulator on hand, we can certainly have them, they're quite accessible, and we can certainly add that to the machine very easily. And there's many options to do that. So by setting potentially operating pressures, standby mode pressures, and shutdown pressure, which is basically turning off the pressure when the machine is not running, we can certainly almost start saving a lot of compressed air just by following those 3 simple preset pressures based on whether the operator does it automatically or whether we program that into a PLC. That's one option. We can program a digital pressure regulator into a PLC over, whatever the preferred network is, or it could be digital or analog interface, or it could be a network interface to a PLC. We can set very simple, if we have that capacity on site, we can set very simple pressure settings in the controller of some sort to lower that pressure when the machine comes to a stop. So we are not feeding leaks into the machine at a high rate, or potentially we could divert that pressure to another process of the actual factory where it's required, while the machine could be sitting for half a day or even a full day at times in idle mode. Another way is if we don't have that capacity on site, we can also leverage of a flow switch where we can preset certain flows. If we know how much flow that machine is using during normal operation, and how much flow or artificial demand exists within the machine when it's in standby mode, we can certainly program a flow switch to output directly into electronic pressure regulator to lower that pressure to standby mode and achieve the same thing without having to have a PLC or as almost as a standalone solution. So, and it's a very scalable solution, so it can be deployed anywhere. So because it has a large varying flows that are available across that setup, we can deploy that on a main line, we can deploy it on a particular part of the process, or even at the beginning of each machine. So it's something that can be very simply added and scaled across the whole factory. Just because we're not measuring it immediately doesn't mean it's not happening. So I'm sure it's going to resonate in the next power bill, or in the next review, or somewhere it's going to turn up saying that we are using a lot less power. Next part of the process, what we can do is potentially what we can have a look at is upscaling functionality on existing machinery. So upscaling functionality in existing machinery is looking at legacy machines that exist currently in our factories, and where can we add smarts to that machine. By adding simple things like a full stroke sensor that will give us closed loop feedback and continuous feedback on an actuator will certainly change a lot of the meaning, understanding where the piston is during the operation. Couple of the immediate examples is by looking on the right-hand side, we can use it for a QA process. Where the cylinder previously, as we know, cylinder being a simple actuator where it extends to its full stroke that it's physically set and retracts back, by having the feedback of knowing where that piston is, there's many advantages to that. So one of them could be immediately applied for checking parts or QA testing for drilling holes, for example. By providing a simple measurement of what the depth of the hole is, we could potentially add a variation of products on the conveyor line that we can test. If you put a pressure regulator into that mix as well, like we've seen before, the digital pressure regulator, we can almost regulate the pressure as well for various products. We can identify that product by size and then understand that we need to either press that product harder, so we raise the pressure, or we need to back the pressure off a little bit to reduce the force on that product, not to crush or damage that product as well. So improving, other than obviously adding some immediate visual and the obvious functional differences to this product as well by adding a linear encoder on there, so to speak, there's other things that we can benefit from that as well. Once we start looking at the data behind that, there's more functionality within that system to be able to understand the speed of the piston as well. How efficiently is that operating? Is the piston running as fast as it used to? Perhaps it needs a seal change. So this is now going into the areas of predictive maintenance potentially as well, or preventative maintenance as well. So there's many reasons that we can explore a solution such as adding upscaling simple cylinders. Now, one of the key things in a basic product like this is there is also the option of connecting in many different ways, or there's at least 3 different ways we can connect from a simple sensor, which is an I-Link connection, which is very popular. and very flexible and the ideal solution. If we're not at that stage where we have on a legacy machine this type of technology, it is a recent technology. Most machines may not have it. We may not have the budget to be able to go to that length. But what we can do is just wire it through just standard on-off switching, or even an analog output into the system as well that can provide us this kind of feedback. It still has the IO-Link capabilities, which we can switch to once we're ready to upgrade the machine. Another solution where we can take the actuators even further. What if we added a higher degree of control to our cylinders and actuators, like controlling the speed or force and also the acceleration? In a previous example, all we know is where the actuator is. Well, what they can do, they can speed up the cycle time on the machine by not having the pneumatic cylinder go all the way back before we start the next part of the process, because we know it's safe to do so and it's out of the way. So we may be able to shave 1 or 2 seconds of the process. Going to that next step up, adding further functionality by controlling speed, force, and position. We could do that in the same way, control the valve in the same way that we control the cylinder, just by flicking on-off switches and not adding further complexity to the machine, and we could achieve a lot more. So one of the options is electric cylinders, and a simple product that we can apply almost immediately to upgrade a part of the process. And this is where the rapid machine adjustment comes in as well. So we can repurpose our machines to accommodate for multiple different products almost immediately without having to add complexity to our PLC process. So it may be a matter of replacing some simple actuators to add further functionality just by storing the step data within the driver itself and selecting through on-off switching, or perhaps we already have a network on the machine that we can integrate into. So another option to explore. Adjusting conveyors for multiple products, potentially filling systems where we can adjust for various size jars or shapes of a jar, viscosity of the fluid where we can use speed to adapt to the viscosity of the fluid and control the filling systems. We can go even further than that. So looking at it, we're still using basic principles and applying basic technology and controls as we have in the previous couple of examples, is we can add further functionality to our machinery where we can coordinate some axes, where traditionally coordinating axes requires high-end PLCs or dedicated PLC motion cards and probably quite a lot of knowledge in programming as well. Having a simple system like the JX2 and 3 options, we can coordinate axes and have the smarts being handled by the driver itself. And still we can select that type of a motion with a simple on-off switching output from a basic source. That could even be push buttons, or it could be just a relay output on a basic PLC, or we can integrate a network such as Ethernet IP or EtherCAT or others. So coordinating axes, where can that come in quite handy? Well, it certainly comes in handy when we're palletizing applications, where it could be as simple as Cartesian axes or palletizing in a certain pattern. It could be inspecting parts, like in the top right-hand corner, where what we need to do is do a QA check or inspect with a laser sensor to ensure that the parameters are correct on a machined part. Or we can also apply glue to an interior of a car part that needs to go in an irregular pattern. So these are very flexible solutions that are built in natively to a system like this, where it doesn't require any specific or high-end knowledge, and it does allow us for rapid deployment as well. So it could be even synchronizing 4 axes, as we see in the bottom right-hand corner, for transporting autonomously parts and shelving them where stability is required and the equal amount of force is required on 4 different corners, and it needs to be applied at the same time with the same movement. So, or potentially even balancing and lifting a platform on 4 different corners that need to be coordinated in a sense that allows that to happen, or perhaps not to damage a product that's on top of the platform. So this is all possible. Stepping across to another side of the factory potentially, it's been known that estimated that a lot of the downtime in robotics is usually caused by broken communication cables. We all seen robots in operation. We all seen the multi-axis movements or quite complex movements where robots are deployed to perform, and they are deployed for that very reason. But perhaps if we could give them a lot more freedom in movement by removing some communication wires. And that's exactly what is available as well. So we can add and remove some downtime on robotics by putting wireless communication, I/O modules, that can communicate to a master in a control cabinet and at least remove one extra wire of the communication line. And what this could do is improve perhaps the speed of the packaging, or we could move in a direction that we weren't able to move because we're free of a one specific wire that didn't allow that to happen. So what it also does is allows a single point of connection with the master module to a PLC that, for example, may have one Ethernet connection or one Ethercat connection available. And what we can do is set up multiple wireless subnetwork modules that correspond to the one master without adding further programming to the PLC. Where that's particularly useful is also by tool changing. As we can see in both of the applications running on screen at the moment, is often we need to change tooling to be able to handle different products in the same or at that part of the process. Where that can happen quite quickly is by being able to have multiple wireless modules connected to tooling equipment. On power up and reconnection, approximately 250 milliseconds or even less at times it takes to power up, and it's back in full production and online and available. So another way where we can add further flexibility to our factory and potentially reduce downtime in broken wires and diagnostics. So having said that, we've seen a few different applications where possibilities, we could open up almost immediate possibilities, and it didn't require anything specific or overly technically intensive or involved. So reviewing quickly on this slide over here, so where to from here? So what we started building an infrastructure. So we started on one part of the process or one section of the machine where we've taken one direction to, whether that be to save compressed air or reduce compressed air usage by lowering pressure at during standstill or standby on the machine, diverting that air to another section of the machine, which in turn, what it does is it stops the compressor kicking in continuously and having to run overtime. Where we are looking at upgrading high-end functionality using simple electric cylinders with slightly more capable drivers that can perform what previously used to be quite complex tasks very simply at our end as well. We can upgrade very simple air cylinders as well by adding smarts to that cylinder, like electronic full stroke sensors and also electronic regulators that can control the force of the cylinder very dynamically as well in coordination with the sensor. And we've also seen wireless systems that can remove wires and allow systems to move freely. And those systems are usually robotics or turntables, stretch wrapping systems, etc. So where to from here, and what are the further benefits that we unlock? So having this type of equipment implemented, at this point, we haven't connected to anything other than the actual functional part of the process. Now, what we have achieved an improvement in the process. Monitoring and data logging ultimately lead to big data analysis, OEE reporting, which is very desirable. And we need to continue having the conversation about digital improvements and the benefits of digital implementation of this type, but we haven't got there yet. But just because we're not yet capturing the data, we're not analyzing the data, it doesn't mean it's not happening. We may be saving that compressed air, and it may be reflected in our quarterly or monthly bill at the end. We don't know exactly how, or we can't pinpoint how much came from each machine, but we have made some improvements to the process. Adding smart functionality to, whether it's through our electric cylinder or a pneumatic upgrade to a cylinder, what we are doing, we may be increasing our throughput. We may have actually added 2 or 3 products per minute to our line that's being produced. That will be certainly picked up in a production report or in the unit count at some point. We may have less downtime by adding a wireless system to our robot at the end of the month when we look at how much stop time there was in the machine, how much downtime was recorded by the operator on a robotic system that had implemented a wireless system. That may be reduced, but we don't know at what point or how, but we are making improvements. So we don't want to stop here. So yes, we have made immediate improvements and there are immediate instant rewards there that we can start applying, but we don't want to stop here on the journey. So what's the next stop? Well, the next stop is to create a scalable platform. So what we do is once we start deploying these systems, these I/O systems, whether that be sensors, whether that be actuators or smartening up our legacy machines, what we want to do is start integrating into a common platform. Now, that common platform could be like an EX600 system that what it does is it helps to facilitate for an ecosystem that grows with your automation requirements. Now, a flexible, which is why we refer to smart flexibilities, we can upgrade at any time. We can add a functional module to this system as the requirement does arise. So once we've preset all the infrastructure and the actuators and the I/O system below that, we can start integrating. We can start integrating via IO link to the system. We can upgrade a certain part if we're at that point with the budget, or the next round of upgrades allows for that type of implementation. Or we can simply continue by wiring it through an analog I/O system or a digital system and find one output or one part of that system that can give us a little bit of diagnostics or a little bit of feedback that might be critical to the system as well until we are ready to upgrade further. So a lot of flexibility exists, and also you can see by even the vast amount of communication networks that a scalable platform like the EX600 can connect to as well. It does allow us to utilize the existing equipment that we've potentially diagnosed in our second step in digital assessment to accommodate for that extra spare capacity that we have. So we don't have to utilize, or we can utilize and not replace everything on the machine. So having said that, and starting to head down scalable systems as such, ultimately, which is going to lead to is the overview where we want to go, which is the gentleman holding the iPad and potentially from the top floor being able to adjust his whole factory. So ultimately it leads to smart factories. And this is what smart factories look like. When we start having interaction with multiple parts of that factory or multiple parts of the process, by being able to understand what's happening by streaming data, by having full duplex of communication, that means being able to send data to individual equipment right down to the sensor level, and being able to interrogate data from each sensor, actuator, or processor on that line. That starts giving us a lot more flexibility. One of the great quotes that I've seen is being able to refer to real-time data other than quarterly management reports certainly makes a significant valuable insight to decision making. So having that data on hand right now, it certainly does give us a lot more ability to respond to a live system as such. So in saying that, we'll pretty much complete our journey on the next step. And the summary and the key points that we've explored was start somewhere. We need to start somewhere. So the key is to take small steps, make it achievable. That's within the budget, that's within our capability. Follow the process, lay out the process into 4 steps in digitalization. Be clear on what we're trying to achieve, how we're going to do that, what we currently have, and who we have around us to support, and the project management team, the timelines and budgets, and let's get a little bit better every single day. So ultimately, that's the key points and summary. So the last slide we're finishing, and we'll go to our QA. So I'm not sure how we're going for time, Nick.
Yeah, I think you've entertained people and they're sticking around. We haven't had anyone dropping off, which is good. So I'd like to thank you, Joe, for your informative presentation. I'm sure we're all taking something away from this. We do have a few questions. I'm getting a lot of feedback. I don't know
Excellent.
why. Yeah, so what I'm going to do is I'm going to read these questions out to you. I'm also going to send them to your device, so you can also look at that. The first question is, and some of these might have been answered already, but it is, in your initial assessment, you mentioned technology and enablers. What is more important driver for change? Is it practical or cultural?
Well, I think that's a wonderful question, and it's certainly there is an element of being able to embrace change as well. So it's both is important as well. So to answer that very simply, so it's important to have people on board, and it's important to have the culture instilled that it is okay to change, and it's okay to move forward in ways that obviously enable us to do better, to be better in terms of what we are doing, how we are doing that to be more sustainable, which ultimately all it does is reaps benefits for the business itself. It allows us to leverage off technologies. Often it's misunderstood, where I think there is a cultural hesitation within the company, or, I mean, it's probably one of the greatest phrases, the 7 words that, we've always done it this way. It's probably never been more dangerous in an evolving climate as we're currently in. And I mean, I think it's a great place to start with the drivers for change, and everybody should be able, that knows that process, that machinery, to be able to see the demanding environment that we're currently in, the manufacturing environment, and also the pressing changes that are upon us. So especially with the COVID adding the final push. But certainly that conversation, needs to happen, and it makes it a lot easier to make technological implementations, and a lot more successfully when we have the cultural backing to do that.
Yeah, of course. Got another question here. I've also sent it to your phone. Hi, Joseph. Do I need to convert a whole production line to see improvements, or can I just start with the bottlenecks?
We can definitely just start with the bottlenecks. And if anything that I tried to get across in this presentation was simply to start somewhere. The process better than we do, or better than anybody. So we know our processes, we know where the shortfalls are, so we know where to look. And perhaps we can't ignore that any longer. So going straight to the bottlenecks, or to know where the improvements needs to happen, as I said, ideally we want to be able to have that full communication right to the top and be able to produce an OEE report at the end of the month. But if we don't have that capacity, which can be also an overwhelming amount to demand in one hit, we can break down that process of getting there, and certainly start with the parts of the machinery that are presenting problems, or we can upscale sections of the machine, or if not the whole machine at once, and slowly incorporate into a common platform. Okay.
Very cool. We do have one comment here. Thanks, Joe. Good to hear about the DMP sensors. So that's just a little bit of feedback there. And Excellent. The last question we have here, just quickly, what are the real-world benefits of upgrading air supply systems to modern actuator styles?
Sorry, so what was that question, Nick?
So what are the real-world benefits of upgrading air supply systems and/or actuators to modern pneumatics, I guess?
Oh, okay. Yeah, well, certainly, I mean, the immediate one is reducing your air consumption. So, I mean, ultimately, if we can do more with less, ideally, the most adding sustainability and being able to do more with less compressed air, it just reduces our production costs. So that ultimately the real world outcome, and the one we desire, is to reduce our resources in energy to be able to produce the same amount or more by being more efficient and being more conservative with our energy use, whether that be compressed air, electrical energy, which we know we use electrical energy through compressors to make compressed air. So air is for free, certainly is, but compressed air is not. Yes. And when we spoke about the cultural changes, that's probably one of the biggest cultural changes that needs to be understood is, compressed air is not for free. And if we use it wisely as well, we will certainly have enough pressure and enough to cover the entire factory, and we'll be able to reduce our compressor usage, and ultimately that should lead to lower power bills.
All righty. Well, that's the end of the questions there. I just want to thank everyone for joining us today. We've had a good turnout. Please join us again in 2 weeks' time. That's the 15th of October, same time, same place. We will have Jim Wallace from BALF, who'll be taking a look at the government assistance for local manufacturers. I guess it's really opportune now, knowing that the federal government is announcing a $1.5 billion cash injection into Australian manufacturing. They say creating 300,000 jobs and securing onshoring, which is great. Jim's going to have some industry experts with him who will be able to answer these questions with regards to maybe gaining some access to some of this federal money. So once again, thank you all for joining us. Thank you, Joe, for your wonderful presentation. If you have any questions, please feel free to contact us through the email address on your screen right now, or if you know us personally, get in touch with us directly. we're here to support and help you guys. Thank you, everybody.